Um, as a reminder, just remember, if you struggle with what you're supposed to move to isolate x, like let's say you have 3x minus 2 equals 5. This is a simple problem, but it serves the purpose of showing you how we do these. So if I have 3x minus 2 equals 5, and I don't know whether I should move the 3 or the negative 2 first, a way that you can get around that is by using this trick that I came up with. Well, I don't know if I came up with it, but like I had never heard it before, and like it just kind of like made logical sense to me, and it helped a lot of students. So when we're doing regular math, like order of operations and stuff, we do PEMDAS, right? Algebra is the opposite of PEMDAS, so it makes sense that the steps for like what do you move in order would be the reverse of PEMDAS, which is SADMEP. So like if you are struggling to determine should I move the 3 or the minus 2, think, okay, SADMEP. SADMEP says I have to move anything that's being subtracted or added to my variable x first, so I have to move the minus 2. How do I move it? By doing the opposite operation, which would be plus 2, adding 2 to each side. Now, this doesn't, someone said like it shouldn't be taught like that. Like, I understand that it doesn't always work. This is for like these types of problems. Again, when you get like fraction bars involved in stuff, then that's a different story. I have different stuff for that. But like this is a really good thing for someone who's like getting every single problem wrong in algebra and like has no idea what to do. This is a great strategy. So, what we're going to do is we're going to add 2 to each side, and then we get that this is equal to 7. This is 3x. We have to now divide next to get x by itself. So it's x is equal to 7/3. And that's basically how SADMEP can help if you're stuck in one of those situations, if you don't see it. No terms are moving. Oh my gosh. Really? But yeah, when fraction bars get involved, just like I know you were kind of trolling, but like for other people, like when fraction bars get involved, what I teach students to do is like kind of treat the top like it's its own equation and the bottom like it's its own equation. And that seems to help students, that combined with this, and they usually get a lot better at algebra from just that. So let's go to number 1. What level of math is this? This is ACT math for people asking. So let's go to number 1. Which of the following is the solution to the equation right over here? So I'm going to distribute the 6 to each of these terms. So it would be 6x plus 12 is equal to, and then 3x, and I have to distribute the negative 2 to each of these terms in parentheses. So it's going to be negative 2x plus 8. So now I'm going to combine my like terms here of 3x minus 2x, and that's going to be just x. So x plus 8, and then it would be 6x plus 12. And then we're going to subtract x from each side, and it's going to cancel out here, and then we're going to be left with 5x plus 12 is equal to 8. Then I'm going to subtract 12 on each side, and then I'm going to get 5x is equal to negative 4, and then I divide by 5 on each side, and I get x is equal to negative 4/5. That's supposed to be a 4, guys, sorry. And that would be E. Someone asked if I can do this with fractions. Yes, there's going to be more with fraction bars on this page. You'll see in a second. So number 2 says 3 needs to be distributed to each of these terms in parentheses, and then we're going to solve for x, and we have to distribute the 2 as well. So I'm going to start by distributing 3 times each of these. So then that's going to be 3x plus 18 is equal to 2 times 4. And then we're going to also distribute it to the negative x. So 2 times 4 is 8. 2 times negative x is negative 2x. So then I'm going to add 2x to each side. It's going to cancel out there. So then I'm going to get 5x is equal to, 5x plus 18 is equal to 8. And then now I'm going to subtract 18 from each side. So if I subtract 18 from each side, I'm going to get 5x is equal to negative 10. And then I'm going to divide by 5 on each side, and I'm going to get that x is equal to negative 2. So it should be J. So let's now go to the next one, number 3. So it says for the equation right here, b equals 5. So that means where we see b, we're going to plug in a 5 for it. So we're going to say 3x plus 5 over 4 equals 20, and then we want to solve for what x is. So we're going to say, yes, someone brought up a good point. If you don't know what if you don't know how to solve this, one thing that you can do is plug in the answer choices to see which one works in this equation. Like you could plug in each of these values in for x and see if you get 20. And if you do, it works, and that's the right answer. But we're going to go the faster route because that's going to take a while and multiply each side by 4. So then that's going to give us 3x plus 5 equals. Now, a trick that I also teach students is whenever you see fraction bar equals, you can cross multiply if you don't see that this is like immediately that you have to multiply each side by 4. And the reason you can do that is because 20 over 1 is the same thing as 20. So you can think, oh, I'm cross multiplying. 1 times that is 3x plus 5, and then 4 times 20 is 80. So that's another way to kind of think about it. And also it tells you like what you need to do if you see fraction bar equals. You can just kind of like immediately think, oh, cross multiplication, and not have to worry about anything else really. So what we're going to do now is we're going to say we're going to subtract 5 from each side. So then 3x is equal to 75. Divide by 3 on each side, and we get x is equal to 25. So that would be, let's see, that's B. Someone said number 1 is wrong. I don't think it is, but I'll double check it. So 6 times x is 6x plus 12, and then 3x minus 2x, that's fine, plus 8. Then we combine like terms here, we got x. So then we subtract x from each side. That is negative 4. Negative 4/5. Yeah, number 1 is correct. Maybe you just didn't see the negative right here. It's negative 4/5. So then let's go and do number 4. If x plus all of this equals, yeah, what is x? We're basically trying to find what x is. Now, for this, I would just subtract 5/7 from each side to get x by itself. So it's going to be 2 over 49 minus 5/7. And remember, when we add or subtract fractions, we need a common denominator. So if I multiply by 7 here, I get 49. So whenever I do that on bottom, I have to do it to the top as well. So I would get x is equal to 2/49 minus 35 over 49. And then we're going to get x is equal to negative 33 over 49, which is just going to be f. Someone asked if I could do the previous problem without the fraction bar. Yes, without the fraction bar, all you would do is say, so like this. All you would do is say, okay, whenever we have this where we have a fraction bar involved equals a whole number, you could say that you just multiply by the number you divide by. So instead of dividing this whole thing by 4, you multiply each side by 4 to cancel out that 4. And then you just get 3x plus 5 is equal to 80. That's another way to think about it. Can you still take the ACT senior year? Yes, you can. Just be careful about like when you're applying to colleges, depending on like if you're doing early decision and all of that, a regular decision, there's different cutoffs for when you can submit your test score. And it's also like really hard to do that plus all your college applications and essays and stuff. So I don't recommend that usually, but you can, yes. This is for ACT math. If 9 plus 3D equals 33, then 2D equals, so we're trying to find out what 2D is. Now, let's basically find out what D is from this equation, plug it in, and get what 2D is. So if I have 9 plus 3D, I just subtract 9 on each side first. That's going to cancel out there. So then I get 3D is equal to whatever 33 minus 9 is. So then 33 minus 9 is going to be just 24. Then I divide each by 3, and I get D is equal to 8. So now I can just plug that in for D over here and find 2D. So 2 times 8 is just 16. Someone asked what is harder, SAT or ACT? It depends on you and what you find hard. So like take a practice test of each and then see which one you're naturally better at and start studying for that one. So the solution to the equation right here. So this is a helpful trick when working with, especially stuff with fraction bars that has variables involved. So a trick that you can use for these is just multiply by the denominators to cancel them out, so then you don't have to work with fractions. So the denominators are x and x minus 7. So I'm going to multiply everything by x times x minus 7, and that'll cancel out my denominator so I don't have to work with fractions. So 1 times all of that is just going to give me x times x minus 7. And then now if I do 4 over x times that, the x and x will cancel out, so then it's just 4 times x minus 7. And then now I'm going to do the equal sign, and I have to do all of this times x over x minus 7. The x minus 7s will cancel out, so then it's just x times x, and I get x squared. So now you see I don't have to work with denominators or anything like that. So I can now just distribute my x to each of the terms here in parentheses. X times x is x squared. X times negative 7 is negative 7x. And then now I'm going to distribute the 4 to each of these terms in parentheses. So then it's going to be plus 4x, because 4 times x is 4x. 4 times negative 7 is going to be negative 28, so minus 28. And that's going to equal x squared. Now I can subtract x squared from each side, and that'll cancel out on both sides, so then it's just equal to 0. So I have that this is equal to 0, and I see that I have like terms here. Negative 7x plus 4x is going to be negative 3x. So now I have negative 3x minus 28 is equal to 0. Now I'm going to add 28 to each side. So then I get negative 3x is equal to positive 28. And then I'm going to divide by negative 3, and I get that that's negative 28 over 3. So then that would be g. So let's now go to number 7. What is the solution to the equation right here? So again, if you have fraction bar equals, I find that most students find it easiest to just put like whatever the whole is over here over 1, because x is the same thing as x over 1. Then they see fraction bar equals fraction bar, which is almost always cross multiplication that you have to do. So then 1 times all of that is just going to give you that same thing, 2 times x minus 3, and then that's going to equal 7 times x is 7x. And then we're going to say, okay, 2 is going to be distributed by to each of these terms in parentheses. 2 times x is 2x. 2 times negative 3 is negative 6. And that's going to equal 7x. So now I'm going to subtract 2x from each side to get the x's together on one side. That's going to give me negative 6 here. And then it's going to be 5x. And then we're going to say, okay, we need to get x by itself, so let's divide by 5 on each side. And that's going to be negative 6/5 is equal to x. So then the correct answer would be A. Thank you guys for sharing and liking the live. So remember, if you need a cramming guide for the SAT or ACT exam, or if you're looking for like any sort of like math courses, I have a lot of different TikTok series that are coming out starting this week. The cramming guide is completely finished, but I am going to start something where I'm going to kind of like create like a course for people where every week they can kind of like check in and learn a bunch of new topics for like different stuff like pre-algebra, algebra, geometry, that sort of thing, grammar, like all of that, which will be like an ongoing series. I'm going to make each of them like $4.99 because it's going to be like a year worth of material basically that gets released weekly. So if you're interested in that, feel free to check out my TikTok series, please. And the cramming guide is already completely done, and that's only $1.99. And it takes you through cramming for both the SAT and ACT exam. So let's go to number 8. So let's see. Okay, we have x to the 5th plus x cubed is equal to 0. Which of the following is a set of all real numbers that are possible for x? So we basically, this one I would just like plug in the numbers because it's easy to do 0, 1, -1. I would say that's the fastest strategy. So I'm going to start with 0. Like if I plug in 0 here, 0 to the 5th is 0 plus 0 to the 3rd is 0, 0 plus 0 is 0. So 0 works. Now I'm going to plug in -1. So if I plug in -1, I have -1 to the 5th plus -1 to the 3rd, and that's supposed to equal 0. Well, -1 to the 5th is -1 plus -1 over here. That does not equal 0, so that does not work. So automatically I can cross out this one, and this one, because they all include -1, which doesn't work. And I can know that it's k because 0 had to work, so part of the answer has to include 0. So let's go to number 9. It says, assume 2x minus 4 is equal to 11. What is the value of all of this? So we're trying to find this. Be careful with these types of problems because a lot of the times they'll put like x in the answer choices because they expect you to find x and think you're done, but you're finding what 3 times x minus 7 halves is. So we have 2x minus 4 is equal to 11. Someone said the last part doesn't make sense. if you want, you could plug in 1 to make sure that like it doesn't work as well. But what I was saying is I can stop here because I already eliminated -1 didn't work. And I knew that 0 had to be part of the answers because it does work. So since 0 is not a part of the only remaining option, other option G, I could say it's automatically K. But you could plug in 1 if you want, and you could say 1 to the 5th plus 1 to the 3rd. That does not equal 0. So then you prove that that doesn't work either. So let's go back to this one. So we're going to solve for x and then plug it into this right here. So I'm going to add 4 to each side. That's going to give me 2x is equal to 15. Then I'm going to divide by 2 on each side and get 15 halves. And then now that I know what x is, I can plug that on in here for x to solve what 3x minus 7 halves is. So 3 times x is 15 halves minus 7 halves. So I'm going to multiply here. That's going to be 45 over 2 minus 7 halves. And then that's going to give me, that would be 38 over 2. And then 38 divided by 2 is 19, so it's going to be C. Yo, you actually helped me pass my SATs. I got 90. Okay, that's good, or but thank you. Got 90. I don't think, oh, well, hopefully you didn't get 90. I don't know if you're joking or not. Okay, so let's keep going to number 10. 3x over 2 is equal to all of this. Then what is the value of x? So we're solving for x. I see a number pressed up against parentheses, so I have to do distributive property, which means I'm multiplying 4 times each of those, and I'm just going to copy down the other side. So 4 times x is 4x, and then 4 times 5 is going to be 20. And then, oh, someone said that it's a different system in England where they have a different exam, and that's what they meant. Oh, okay. Yeah, I was like, a 90? I don't even think you can get that. I think you get credit just for, like, signing your name. Let's keep going, basically. Okay, so we're going to now get the x's together on one side. So we're going to subtract 4x from each side. So then we have 3x over 2 minus 4x is equal to 20. Now, remember, when we are subtracting with fractions and we have a fraction here, we have to have a common denominator. This is technically minus 4x over 1, so to make it have a common denominator of 2, I have to multiply the top and the bottom by 2. That would give me 3x over 2 minus 8x over 2 equals 20. So then I'm going to keep my common denominator of 2 and subtract across on top with my numerators, and I get negative 5x, and that's going to equal 20. So then I'm going to multiply each side by 2, and I get negative 5x is equal to 40. And then I'm going to divide by negative 5 on each side, and I get x is equal to negative 8. So the answer should be G. Someone asked a question, hold on. Isn't it negative? Yeah, it is negative. Would you be able to cross multiply? Oh yeah, you could cross multiply if you want to. You could have said times 2 on each side. Every time I see distributive property, that's kind of like just what I start with, typically. So you could do that too, yeah. Let's keep going. So number 11, this is for the ACT for people asking. So let's go to number 11. The amount A that a house is worth over T years is shown in the equation above. P is the initial price and R is the annual rate of growth. Which of the choices below represents R in terms of the other variables? Okay, so we're solving for R. Remember, the in terms of trick means that we're solving for whatever's in front over here. We can also see in the answer choices they're getting R by themselves. So we want to move everything away from R, starting with the P. We have to divide each side by P. And that's going to leave us with 1 plus R to the T power. And then now we have to get rid of that T. So we have to now, do you all have, sorry, I'm going to answer questions after this. Sorry, I'm getting distracted. So then we are going to do the opposite of T, which would be taking the T root, basically. Like just how if you had x cubed equals 8, to get x by itself, you would take the cube root of each side, and you would get that x is equal to 2. It's the same type of concept, except we don't know that that's a 3, it's a t in this case. So it would be the t root of a over p is equal to 1 plus r. And someone asked, why do I move the p to the other side? So let me show you. So, this stuff is parentheses. Like, this is parentheses. This is why SADMEP can help sometimes if you don't know what to move first. So you have to move anything being subtracted or added, but that doesn't include if it's in parentheses. And then you have to next move anything that's being divided or multiplied, which would be the p, so that's why you move it first. So now we're going to say 1 plus r is equal to the t root of all of that, and we want to get r by itself, so we're going to subtract 1 on each side. And we're going to say that we have the t root of a over p minus 1 is equal to r. So that would just be h. I understand this IDK how? Well, I'm glad you understand it. Isn't it PEMDAS? Okay. Yes. So PEMDAS is something different. It's the opposite, basically. So PEMDAS is for like when you're doing regular math, like order of operation stuff, like the normal way that and direction that math flows. What I teach my students that I found was helpful a couple years back is learn about SADMEP to help you decide how you're going to move things to solve for a specific variable. So like when you're solving for x or solving for r, SADMEP tells you what you move first. And it's what can be really helpful with those. Now, when fraction bars get involved, it gets a little iffy. But when you have just like a simple, straightforward problem like this, where you're just solving for r in this case, SADMEP would tell you what you move first and all the way to last. And it's the opposite of PEMDAS. It's the reverse, like it's PEMDAS spelled in reverse because algebra is the reverse of regular math. Is kind of like how I get students to remember it too, logically, because instead of just doing like regular order of operations, PEMDAS, we're solving for x. We're going backwards. So now we got that that's equal to h. So now there's a bonus question for this chapter. Solve this without a calculator. And this right here, what is the value of xy? Okay, so remember, if you have x minus 2y squared, that's the same thing as x minus 2y times x minus 2y. And that equals x squared plus 4y squared minus 10. So here we have two terms plus or minus in parentheses, so we have to FOIL this out, which is an acronym that stands for what we're multiplying together. F stands for multiply the first things, x times x is x squared. O stands for multiplying the outer terms, so x times negative 2y. So that would be negative 2xy. And then negative 2y times x is negative 2xy. I'll answer questions in a second, guys, by the way. And then negative 2y times negative 2y is the last things that we multiply, so that would be plus 4y. And that all equals x squared plus 4y squared minus 10. Now let's combine our like terms of negative 2xy minus 2xy, so that would be x squared minus 4xy plus 4y, oh sorry, 4y squared. Sorry, I got distracted when I was telling people that I was going to answer the comments. I just saw that. 4y squared, and that equals x squared plus 4y squared minus 10. And then now what we're going to do is you can say that like you see the same thing on each side so they cancel out, or like how that logically works is we're going to subtract x squared from each side. And then we would get also like do the same thing with the 4y squared, so minus 4y squared over here. Those would cancel out, and then we're just left with minus 4xy is equal to negative 10. So then divide each side by negative 4 to get xy by itself, because remember that's what we're solving for. Xy is equal to, and that's going to be 10 over 4, because the negatives would cancel out. And then we would just divide by the greatest common factor of 2 on top and bottom. So then this would become 5 halves, or 2.5 if you want to do it like that.